Facebook. So we're going to start with section 4 in chapter 1. So we're going to start talking about functions first. Are there any questions? So as you can see, I kind of typed up half the notes for you so that you don't have to write it all down. All right. All right. So we're going to work on this together. So we have f of x. So can I write on this? Some reason it's not letting me write on it right now. Hold on for a second. Hold on. All right, I just opened one and it worked. Okay, so this is f of x. That's how you say it. F of x. That's function notation right there. Now, it could be any letter. It doesn't have to be F. It could be any letter of the alphabet. I could have put T of x if I wanted to for Thomas. But for the most part, you're probably going to see F of x for most of the functions you see. Can anybody give me a guess why you think you normally see F of x instead of other letters?
Because it's a function, right?
Right. Right, Kara. Because function starts with an F. All right, so that's why you probably see F of x most of the time. But they may change it. For example, if we're talking about a business application, they may say P of x for profit function, or C of x for cost function, or R of x for revenue. So it doesn't have to be F of x, but that's what you normally will see. All right. The input is, what is it this pointing to? The input. Y'all see where it's pointing to? What is the input according to this little diagram? All right. I'm just going to tell you. Input is the x value. So your x value is the input. Your y is the output. All right. So just some little notes you can write down, especially if you printed them out. Go ahead and write on the side of this. If not, just go ahead and write everything down for today. But from here on out, just print everything out. All right. Now, did you know, and I'm looking at this over here, did you know that f of x is the same thing as y? Yes, this means that f of x equals y, or y equals f of x. Okay, so you all are used to seeing y equals something like y equals x squared, right? And now we're changing it to f of x if it's a function. If it's a function, we put f of x instead. Let's talk a little about what functions sort of mean in real life. So basically, your output has to go to only one y, or only one output. For example, I think there's an example in the book, in the textbook, that talks about temperature in the daytime. So let's just say our x was time of day and our y was temperature. All right, so it's 4:19 right now. Does anyone know what the temperature is outside? Do y'all have an app on your phone or your smartwatch?
98, Amy.
98, woo, 98 degrees. All right. And now, about 10 o'clock, what do y'all think it'll be? Let's just say 10 o'clock. We're going to make up something. What's the temperature? About 78?
Or like the 80s.
About 78, 80. I'll put 78.
I do, yeah.
But what if someone else said at 10 o'clock tonight it's gonna be also 10 degrees outside? Does that sound right to y'all? That 10 o'clock is gonna be two different temperatures.
Yeah.
That doesn't make sense, does it? Right? It's either gonna be what it is, or it's just gonna be what it is. It's not gonna be two. It's not gonna be 10 degrees at the same time. It's gonna be 78 degrees. So your 1x, for example, if it was 4:19 p.m., it's only gonna go to 98. It's not gonna go to two different temperatures. Your 10 o'clock is only going to go to 78. It's not going to go to also to 10 or to 55 or to 105, or it's only going to go to 1y. That's a function. What's not a function is when you're saying that 1x is going to more than 1y. For example, again, if you're saying the temperature is two different temperatures at the same time for right now, that doesn't make sense. All right, because wherever you are, that temperature is what that temperature is. You're not gonna have options. All right. Another example: if you go to the post office and you put a package to weigh it, let's say I don't know how so many pounds, it's gonna be based on those pounds. It's gonna cost so much money, right? Let's say you took a package to the post office and it was $10 to ship it. It can't also be with that weight. It can't also be $100 to ship that same package. That's not a function. It's not functioning properly. All right, so that's not a function. When you put the key in your car's ignition, what do you want to happen? So your X is put the key in and turn it. What do you want to happen after you turn the key?
I want the car to start.
You want it to start every time, don't you?
Yes.
But what if it gives you options, like it doesn't start some mornings and that's not functioning right. That's not a function. Okay, you want to be able to predict if for this X you always get this Y. You don't want to have options for Y. So that's what a function is in real life. All right, and you're gonna kind of see the connection with it in algebra, and we'll talk about that. Are there any questions so far? Any questions yet? Okay. All right. Is it Barra Patrick?
Yes, ma'am.
Oh, Barra. Y'all have I like y'all your nicknames. I love it. Cause I've never heard of Barra before. I really haven't. And Kine, I never heard of Kine. Marvion, Nakiria. So yes. All right. And y'all get ready because I'm gonna do attendance and I'm gonna ask for see your faces at some point. So just get ready for that now. All right. For now, I'm just want to get ahead and get some lesson in, and then we'll get to attendance. All right. So you never know when I'm going to call attendance. Just letting you. It could be in the very beginning of class, could be in the middle, could be in the end. All right. Let's move on. Evaluating a function. That's what we want to talk about next. Evaluating a function. And let me read the definition. You know, I was discussing, I'm the math person. I was discussing, having a discussion with my husband yesterday. He was saying he wish he had known that really a lot of the math is really understanding definitions, right? And just memorizing certain things, right? It's really about definitions. So if you say evaluate this function and you don't know what that means, you don't know what evaluate a function means, then you're gonna be like, that's hard. I don't know what to do. But once you realize what it means, you know what to do after that. So let's go over. To evaluate a function is to replace or substitute its variable with a given number or expression. Example, evaluate the function f of x equals 3x minus 4 for x equals 5. All that means is replace the variable x in this right here, replace the x's with a 5. For example, we have f of x equals 3x minus 4 here, and down here I'm replacing, I highlighted it even. The x is a 5. I'm just replacing that x right here with a 5. Placing this x with a 5. And of course, if we're putting a 5 right next to that 3, that indicates multiplication. So a good tip would be wherever you see an x, just put a parenthesis there for the first step. And then what we're going to do is rewrite f of 5 on the left side and do our algebra on the right side. So 3 times 5 is 3 times 5, 15. And then we bring down our minus 4. 15 minus 4 is
11.
11. Simple as that. That's you just evaluated a function. Now let me ask some questions because I don't want this to go over your head. What was the x in this situation?
Was it 5?
5.
Yes, it was. We replaced every x with a 5. Ooh, we're gonna have to think about this one. What is y in this situation?
Is it 5 also?
No, we
Is it
plugged in
3?
5 for x. We
11.
plugged in
It'll be 3, right?
11.
7.
Oh,
Because we said x was the input, right?
Right.
What did we plug in? We plugged in a 5, correct? All right, we plugged in a 5. So our x, or our input, was 5. Our y is our output. What came out? 11.
So basically, the output is the answer, or
Yep, the output is the answer. So, and again, y equals f of x, right?
oh,
In this
okay.
case, right? You getting it? See? And
Yeah.
in this case, it was f of 5, but it's still y. F or whatever. It's still y. Y'all get that?
Yeah.
So that's why they say y equals f of x, because what pops out is your f of x.
So basically, Miss Thomas, everything after the like the f of x, everything after that you supposed to like solve.
Yeah,
And
all
then,
you're doing is doing your algebra. That's all you simplifying on the right side for the most
okay.
part. That's all you're doing. So I could even, since y'all know that, we could even, if we wanted to, write that as a point, a coordinate point. So what is a coordinate point? When you have x and y, like that, right? So what was x again for this case?
5,
5
5,
and
and your y was
11.
11.
11. So guess what? You could graph this if you had more than one point. And we're going to keep on going. It's going to all click together. If you just look at this stuff, just take time, even outside of class, to look at it a couple hours every other day or so. It depends on the person. You have to know how long you have to spend on it for it to start clicking. Usually, once it starts clicking, you're like, oh, this makes so much sense. But if you're not looking at it, it's not gonna make sense. You're gonna be like, what? I don't get it. Okay. But so you may have to spend every day looking at it. So you have to know what your threshold is. Somebody else may say, oh, I did this already. I know what she's talking about. They may can look at it for an hour or two before the test. But you may have to look at it every day. So don't look at what other folks doing. You figure out what your threshold is, what you need to do to be successful in the class. All right, we're going to use this same function right here. But what I want you to do is evaluate the same function f when x equals -3. When x equals -3. So again, let me rewrite the function over here. F of x equals 3x minus 4. But we want to evaluate this function f when x equals -3. So again, all we're doing is replacing what with what?
X with -3.
X with -3. That's all we're doing. So what I'm going to do is change colors. Maybe I'll change to purple. Purple my favorite color, by the way, y'all. -3.
Mine too.
Yep, see? All right. So on the left side, all we're doing is just rewriting back to flag. For negative 3 equals, all right, 3 times negative 3,
Negative
negative
9.
9. All right, minus 4. So f of negative 3 equals
Negative 13.
Negative 13.
negative 13. All right, so you just evaluated that function at x when x equals negative 3, or sometimes they say at x equals negative 3. All right, I have a question. Somebody, if I said, what would be, if I asked you to write a point for that one, what would be the point?
Negative 3
3
and negative
and negative
13.
13.
Good. So we came up with 2 points already for that one function, which means you could graph this if you wanted to on a coordinate plane. You can graph functions already. You have an idea how to do it, at least. We'll talk about graphing a little later in the class, not today, but maybe on Thursday or next week. We'll talk about graphing functions and using the information that you have right here. All right, very good. We're moving on. We're going to keep this same function. Do we have any questions yet? All right. We're going to move on to when x equals 0. When x equals 0. So f of 0 equals, and I hear a little background noise. Is it are y'all in a car or something somewhere? I hear a little background noise. And you're in the car?
Yes, ma'am. I'm here.
All right, so when you want to talk, just turn your mic on then, because we hear that little all right. So f of 0. All right. What does it mean, somebody? Tell me. F of 0. What are we doing? We're going to use the same function again now. Let me go back up here.
And then you put 3 in parentheses 0. And then you put the minus 4.
Yep.
Then you put f of 0 again. And then you're going to put, you put your equal. Then you put 0 minus 4. And then you're going to get negative 4.
Correct.
Or negative 4.
0 minus 4 is negative 4. All right. Pretty simple, right? Any questions? That was it. That was all, folks. All right, so let's move on to x equals w. Same thing. Don't get flustered or anything because it's a letter. We're still evaluating the function, which means we're just substituting its variable with a given number or expression. In this case, it's just one letter. So f, I'm going to go ahead and rewrite everything. But instead of numbers, we're just going to plug in w here. Can't really do any algebra here. It's just 3w minus 4. Can I subtract 3w and 4?
No.
No, and why not?
Because it's not factorable.
Not factorable.
It's the word, not it's not a function.
No, that's. Give me some reason why I cannot. Okay. They are not like terms. That's what I was fishing for. They are not like terms. All right.
I'm just talking.
Oh, here we go. That's Zoe. All right. Y'all gonna get extra points for C. I gotta surprise you with that now. You can't surprise me with your surprise. All right. X equals 2w. Let's go on to that. X equals 2w. So again, a good rule of thumb is you could just put a parenthesis where you need to replace your x with. So this time we're replacing the x's with what?
2w.
2w. You might have to do a little something here. I have to do a little something. So f of 2w equals, what do you think I need to put next?
6w.
6w.
Minus 4.
Yep. 3 times 2w is 6w. All right. See, we're on the roll. We are doing good. Moving on. Next It says when x equals w plus 1. That's okay. We're doing the same thing. I just make my parentheses a little wider. That's all. All right. Again, come on, color. W plus 1, W plus 1. So f of W plus 1 equals, what do I do now on the right side?
3W plus 3 minus 4.
All right, what is that called? What did you just do? What, give me some math terminology.
Cross multiply.
Factor.
Factory.
Not factor, not factoring.
Distribute.
Distribute. I like
distribution.
that. Okay. Distribute. Distributive property. I like all those terms. All right, so distribute. All right, so yes, 3W plus 3 was correct. Minus 4. Are we done?
No, you got to combine like terms.
There you go. We got to combine like terms, so we are not finished. So we have 3W. What else we have?
Minus 1.
Minus 1. Very nice. Very nice. Done. 3W minus 1 is the answer. All right, how are we feeling? Feeling good so far? Any questions? All right. Well, we're going to move on to the next function. Notice we switched the letter up to. How would you say this? How would y'all say that? How would you say
G
that?
of X.
G of X. Nice. Nice. G of X. And then this is what it's saying in the first little rectangle right here. What does this mean? What are we doing? Because I want y'all to be able to look at it and know what to do and not depend on me to explain everything. So what are you supposed to do with this?
G of 0. So
Everywhere
you got an X, you'll plug in 0.
Very nice. We're just plugging in 0 for where every spot we see an X in. So, yeah, I think I can squeeze this here.
Huh? I'm in class. Oh,
So, who is that, Zoe? Who is that? Your little cousin. Hey, little cousin. That's all right. That's all right. All right. So we're gonna plug in a 0 here and a 0 here. So G of 0. What about this first little part? What does negative 3 times 0 squared? What does that end up being? First little part.
0.
Yep. Then we got another 0. Really redundant to write all that, but that's all right. I want to make sure you got it. So G of 0 equals what?
Negative 1.
Negative 1. Very nice. So for this particular function, this is a whole different function. Now, let me ask this question, see if y'all know this. F of x equals 3x minus 4. Do y'all know what shape that is? If you had to graph it, do you know what shape that would have been? Or how would it look on a graph? If you don't worry about it. Let me ask another one. Would you know what shape that one is? That might trigger something. All right. This one would be a parabola.
Okay.
In layman's terms, what does that look like? If you had to simplify, like a U, it'll look sort of like that, or like this. Okay. And then, so what about this one? This first one that we did.
Would it be V-shaped?
That's a straight.
This is
like a square.
Yes. Either like that or either like that. It's a straight line. So how do we know that? By the degree, we call it. No, the degree. Anybody know what degree means? In terms, you may not.
The highest exponent?
Yes. Highest exponent. All right. So what's the highest exponent here?
1.
1. Yep, it's right here. X, you don't see it, but it's understood to be 1. X to the first power. So anytime the highest exponent is 1, it's going to be a line. It's linear. So this is a linear function. All right. So this one, what's the degree of this one? What's the degree of that?
2.
2. Because this is the highest exponent right here. 2. All right. So when the highest exponent is a 2, then it's a quadratic function. It's gonna look, when you graph it, it's gonna look like a U. All right. So just asking those questions, because if you graph this using these points y'all are coming up with, they're gonna end up curving at some point into a U, not a straight line. So it's kind of important that you know how things look even before you start graphing things. You should kind of know what the behavior is gonna be, because if you don't, you're gonna end up trying to make a line and it's not even a line. All right, let's go move on to the next one. The next one is challenging. We're gonna plug in a negative number into the function. So again, we're just plugging in -1. So I'm gonna write it out, but I want to see if y'all can figure it out on your own. All right, I might have to erase some things because it's not letting me draw. Don't know why. All right, hold on. Let's see if sometimes you have to fool the computer, y'all. You have to do something to throw it off so that it can work. So let me do a new document right quick. Okay, that worked. There we go. Nope, that didn't work. All right. Oh, there it goes. Don't know why it does that, but okay. All right, so that's -3 times something squared plus something minus 1. The something in this case is -1. So I want y'all to just work on it. -1 here, because this can trip you up if you're not careful. This one can trip you up a little bit. So I want y'all to look over it twice and see what you think.
So with that one right there, ain't you gonna multiply the -3 times the -1, which would be 3, then you square it, and when you square 3, it'll be
That's what people normally do and make that mistake. So anybody know what you supposed to do first? And instead of that negative,
combine like terms.
not yet. We're gonna work on that first part though. Let's do this first. All right, so
order of
not
operations.
yet. All right. Oh, okay. I like that. Order. Did y'all hear that? That's nice math terminology right there. Order operation. What do you mean?
We gotta get rid of the parentheses first.
Oh, we have to focus on the parentheses first. Y'all remember some of the called PEMDAS or something? They may have changed it. I think one of my students said they changed it to GEMS now. It's not PEMDAS anymore. What do you say, Tyler?
I thought it was still PEMDAS. Ooh,
They changed it to GEMS though. So I learned so much from y'all. Yeah, one of my students was like, no, they changed it to GEMS. G stands for grouping symbols or something. And then he said exponents. Then he said multiplication, division from left to right, something like that. It was cool. It was cool. All right, so I learned something new. But yeah, I'm gonna hold on to the PEMDAS because I'm old school. But it was good though. It was good. All right, so we are gonna do the parentheses first because that's what the P stands for. All right, so -3 times -1 squared. -1 squared is what?
1.
1.
All right, and then that positive times that negative. You know that's -1. Yep, I'm just gonna drop that plus because the negative dominates. G of -1 equals, so that -3 times 1 is -3. All right, and I'm just going slow. Make sure you catch it. What is -3 minus 1?
-4.
-4.
-4. Drop down to -1. So the final answer is g of -1 equals,
-5.
very nice, -5. All right. So if you didn't get that right, especially focus on this one, because that's why I did one similar to that one, because a lot of people do they forget that PEMDAS rule where you have to focus on that exponent first. So try g of -2. I'm gonna give you 60 seconds to work on it. All right, so what should you do first here? What should you do first here?
Working parentheses.
All right, -2 squared is
4.
4. I'm going to just write down -2 minus 1. All right.
You want to
-3 times 4?
-12.
-12. I'm going to write down everything else. One step at a time. -12 minus 2.
-14.
So g of -2 equals what?
-15.
All right, -15. If you got it right, great. If not, just keep practicing. Now I know I need to work on putting your homework up so y'all can start working on it. So I'll try my best to get that homework in either tonight or in the morning. We'll see. Probably tonight. A piecewise defined function. Let's talk about another type of function. This is called piecewise defined function. So a piecewise defined function is basically a function that has more than one piece to it. All right, so look at this. Right here. There are actually two different pieces to the function. All right, so this function behaves as x squared plus 1 if the x is less than 0, and it behaves like x minus 1 when x is greater than or equal to 0. All right, notice that they don't overlap. If y'all look at this, these x's never overlap. If they overlap, we have some problems. All right, so they don't overlap. All right, so when they say evaluate the function when x equals -1, let's just stop here. We're going to look for where does -1 fit in. So x is -1 right here. Is -1 less than 0? Or is -1 greater than or equal to 0? Which one? Less than 0. Less than 0. So we're only going to plug in -1 into the first piece because it only meets the criteria of it being a number x that's less than 0. All right. So for f of -1, this first one, we're only going to plug in -1 to the x squared plus 1 piece, not the x minus 1. Remember, I told you earlier, what is a function? When you plug in 1x, how many y's do you want to come out for it to be a function?
Just one.
Just one. Now, if you're coming up with multiple y's for that 1x, that is not a function. And it's implying right now that it is a function. If it said f of x, it's implying that it is a function. So it's supposed to be behave in a way where if you plug in 1x, you get one y. You shouldn't get two answers, two y's for this one function. All right, so we're going to work on our simplification. So f of -1 equals -1 squared is
1.
1 plus 1. So what is f of -1 equal to?
2.
2. Done. All right. So if you have a question about that, let me know right now. We're going to move on to the next one if you don't. All right, Zoe, what's your question?
Okay, so I do have a question. So I'm not understanding how we.
Okay.
You're saying like I'm not understanding how we were supposed to plug it into the first problem.
Okay, because this first case, x was -1, right?
Yes, ma'am.
All right. Let's look at it. We only have two scenarios in this problem. When x is less than 0 or when x is greater than or equal to 0.
Yes, ma'am.
Which one does it satisfy? Which criteria does it satisfy? Is -1 is our x, right? For this particular case, is -1 less than 0 or is it greater than or equal to 0?
Okay, it'll be less than 0.
Right, it's less than 0. So that's why we're only gonna plug into the first piece.
Okay.
Now, if it was greater than or equal to 0, we're gonna plug it into what? The second piece. Just like this one, f of 0.
Okay.
So for f of 0, this one, in this case, now I know I'm asking very, very simple question, but I want you to catch it. What is x in this case?
-1.
For this second problem right here. We already did that first one.
0 or 1.
0. X is 0 right here, right?
Yes, ma'am.
Anytime you have something right here, that's your x. All right. So x is 0.
Okay.
So we got to figure out which piece, the first piece or the second piece, we need to plug the 0 into. Is 0 less than 0? Yes or no?
Yes, ma'am. Okay, so will you arrow pointing? Well, you just had the arrow pointing. So that's gonna always be given to us, right?
Oh, this part over here.
No, ma'am.
This part right here.
Yes, ma'am. Those parts.
Yeah, I tell you what the x is.
Okay.
But you got to figure out which one it satisfies. First piece, second piece, third piece, fourth piece, depending on how many pieces are in the function. All right.
Thank you.
But the nice thing about it, they don't ever overlap. So it's only going to be one of them. If it ends up being two of them, that's not a function because you're going to end up with two y's. And we already said you can't have for that one x. You want to know what the y is. You don't want to have options of what y can be. It can be this, it can be that. Nope, that's not how functions work. All right, so f of 0 definitely satisfies this condition because it is equal to 0, right? X is greater than or equal to 0. Yep, 0 is equal to itself. So that's why we're only going to plug it into x minus 1. So 0 minus 1. You can put a parenthesis there you want to. It doesn't matter, does it? So 0 minus 1 is, what is f of 0 equal to?
-1.
-1. All right. Now let's do one more. F of 1. So what is, for this case, what is x? What is x?
X is greater than or equal to 0. So you'll do x minus 1.
So what is the x? I'm just asking a real simple question. What is x?
Oh, it's 1.
X equals 1 because it's inside this parenthesis right here. That's what we're replacing the x with, 1. So x equals 1. And yes, 1 is greater than or equal to 0. Therefore, we're only going to plug it into the second piece. 1 is not less than 0, so we're not going to plug it in this one. We're only going to plug it into the second piece. So again, that parenthesis is really redundant. There, you don't need a parenthesis. 1 minus 1 is what? So f of 1 equals
0.
0. Now, if you graph this function, it's going to act two different ways depending on where x is. Tell me, what is the shape of this piece of the function? What's the shape of this one?
Parabola.
Yep. And again, simplify for me. That's gonna look sort of like a what?
U.
Yep. Very nice, like a U. All right. The other one, when x is greater than or equal to 0, that's part of the graph is gonna look like what?
It's linear, so it'll be a straight.
Very nice. She said linear and everything, just making me proud. All right, linear. Yeah, that's a nice math term, linear function. So that'll be a straight line. So that's going to be an ugly. Piecewise functions are kind of ugly because one piece of it is going to be curving like a U, and the other piece is going to be straight. It's going to look weird. All right. All right. I want, for this problem right here, I'm going to go back anyway. I said I was going to skip it. Can someone tell me, for this function right here, can you tell me one point that's on this graph? That g of x function. Tell me one point that's on that graph of g of x. Making you think.
-1.
A point. So when I say point,
-1, -5. Oh, I'm sorry.
Okay, so you took this one.
Yeah.
-1, -5. So yep. Okay, that's not working out for me. -1, -5 is a point. And who was that? Was that Ken or Maurice? Who said -1, -5?
Maurice.
All right, Maurice. Someone other than Maurice. Give me a point that's on the graph of g of x.
-2, -15.
Very nice. -2, -15. Someone other than Maurice and Zoe. Tell me another point that's on the graph.
0 and -1.
0 and -1. And again, if you didn't realize it, we're just really just taking the information from these problems we already did. Those were the x's, those were the y, the corresponding y's to those x's. So you sort of kind of, we haven't graph functions yet, but you kind of sort of understand the foundation of graphing functions already. All you need, plug in x's and you get your y's, and those are your coordinate points. All right, let's try another one. All right, another piecewise function. How many pieces are involved here? I know it looks a little strange because it's kind of off kilter here, but how many pieces do you think there are in this one?
5.
3.
3, actually.
Oh.
All right, so we have this one, 4 minus 5x. So this is 1. This is 1. This is another one. This is another one. So 3 pieces to this one. All right. Let's see if you can figure out what this table means down here. All right. So what do you think we need to do with this? We got a -3. It says complete the table. Can anyone explain? I want to see if you can figure out without me always explaining every detail. What you think?
I guess you just see which category goes in.
Say it again. Let's see. Okay, Alicia, I see your mic still on. What did you say, Alicia?
I was saying you'll plug in a -3 where the x is.
All right. Okay, plug in -3 where the x is. There are 3 options. So what are we gonna do now?
You're gonna see which one fit the problem.
All right. Good. Good. We're gonna look to the right and look at the criteria to determine which piece to plug in. So, for example, does it meet this criteria? Let's start with the first criteria. When x is less than or equal to -2, is -3 less? That's my x right here. Is it less than or equal to -2?
Yes.
Yes. And notice is if it meets one, it's not going to meet the other ones. All right, or that's a problem. All right, so let's put here f of negative 3 equals, tell me what to write on the right side. Anybody?
4 minus 5x.
All right, but instead of an x, where are we going to put?
You're going to plug in a -3.
-3.
There. Very nice. All right, so f of negative 3 equals 4. What goes after 4?
Plus 15.
Plus 15. Nice. F of negative 3 equals 4 plus
19.
15 is 19. Done. Done with that problem. All right, good. All right, let's move on to the next one. X is what in this case? What is X? And again, this is telling you. Right. This is telling you these are the X's right here, y'all. These are the X's. So this is that's why I kind of want y'all to be able to read the tables. All right. So at the top it's saying this table is saying the X's are in the first row. So when X equals 4, okay, now I gotta figure out which piece am I plugging in 4 into? The first piece, the second piece, or the third piece of this function?
The
So
third.
you'll plug in the third one.
Very nice. All right. Because 4 is greater than or equal to 2. 4 is greater than 2, so it meets the third condition. So F of 4 equals what I put on the right side.
4 squared plus 1.
4 squared plus 1. Nice. F of 4 equals 16 plus 1,
plus 1.
which equals
17.
17. Done. Moving on to -1. First piece, second piece, or third piece? Which one is it? This is the second one. -1 is between. This is what it means. X, numbers that are between -2 and 2. Numbers that are between -2 and 2. -1 is on the number line. -1 is between -2 and 2. All right. So, what do y'all think the answer is? F, this one is a little strange. F of -1 equals what?
0.
0. We didn't even have to do anything. It's telling us it's always going to be 0, no matter what. And if you put 1.5 in there, if your x was 1.5, your answer will be 0. If your x was 0, it will be 0. If your x was 1.7, then your y would be 0. All right, so you didn't have to do any work with that. Just write it down. What if I ask you all, and I'm doing this off the cuff, what about F of -2? I want you to work on that. I'll give you 30 seconds to work on that. F of -2. F of -2. Did someone say something? I feel like
14.
Oh, 14. Well, how did tell us how you did that, Maurice. What did you do?
X -2 is less than or equal to -2. So 4 minus 5x will be 4 minus 5 times -2.
Okay, so he said that it meets this condition because it's got an equal to here. So he plugged it into 4 minus 5x. So F of -2 equals 4
plus 10.
Plus 10. Very nice. Which is 14. All right. Why didn't it meet this condition? It's a -2 right here.
Because it's not between
it has to
the
be
two.
between it, yeah.
Yeah, it's between. Because what's missing on that one? Now, if that one said equal to, if this was equal and this wasn't an equal, then the answer would have been 0. But it doesn't have equal to here. All right, it's saying numbers that are greater than -2, numbers that are, this side is saying numbers that are less than 2, and this side over here is saying x values that are greater than, if you wrote it from left to right, greater than -2. So yeah, it doesn't have an equal to sign on that one. All right, let's get to a cell phone costs $49 a month. And this is an old example. I don't know if they still have these plans for cell phones. A cell phone costs $49 a month. The plan includes 500 free minutes and charges 25 cents for each additional minute of usage. The monthly charges are a function of the number of minutes used, given by this function right here. It's C of x. What do you think why they put C of x instead of F of x? What do you think C of x stands for? The C in C of x stands for?
The charge.
Probably charge, or maybe cost, right? So let's try to understand what this piecewise function is saying based on this scenario. So where do you think the 49 came from?
The monthly cost.
All right, the monthly cost, very nice. If, and it's saying this, they gave us this inequality. What do you think? What is the x representing here? What is the x representing? Any guesses? Based on this scenario, you can read it back over. What do you think the x
It's the minutes.
Yeah, x represents the minutes. So here it's saying, what do y'all think this first piece is saying then? The cost is what? If what? The cost is?
If the minutes are less than 500.
All right. If less than 500, then the cost would be
$49.
$49. Very nice. However, what do you think this means? This piece right here. However, if
it costs more, it would be 25.25.
Just as a piece. Just this piece right here. Tell me what you think this means right here. We just said what the x represents, right?
A number greater than 500 minutes.
Okay, so if the minutes are over 500, if you decide to talk more than 500 minutes, all right. Now we got to go to the left. We got to try to understand the left part of this. Then it's $49, right? Plus something. All right, let's go to the parentheses first. What do you think this x minus 500 means? Why we have x minus 500? What is that?
Because everything
represent?
over 500 is what they charge.
Very nice. Everything over 500. So if you went over 500, let's say you did 600 minutes, then that's 600 minus 500. So you're 100 minutes over. And what are they going to do with that? What does this 0.25 mean?
Multiply it by 25%.
Oh, that's where the 25 cents is coming from. That 0.25 times that 100, for example. So that will give you how much you have to spend if you went over 500. Very nice. I want to see if you can interpret that with the scenario. All right, so let's look at this one. Find C of 250 and interpret your results. If it was C of 250, would we look at the first piece or the second piece of this piecewise function?
The first
piece.
First piece. And what would be the answer?
49.
49. Because if you only use 250 minutes, then you're only going to be charged $49. All right, so I just interpreted for you. All right, what about C of 500? First piece or second piece?
The first piece.
First piece again, so the answer would be
49.
49 again. All right, what about C of 665? First piece or second piece?
The second piece.
Second piece. I want y'all to work on that. All right, so C of 665 equals, I want y'all to put down what the right side should look like. Write down what the right side should look like. All right, so again, we're evaluating piecewise functions. So all we're doing is making a substitution, 665 instead of the x. So what would you do first? Now that you worked on the list, I would too. I would work on this parenthesis. What goes in parenthesis? 665 minus 500. 165. All right, what would you do next?
We'll multiply it by 25 cents.
I would. That's what I would do too. All right, so I just write that 49 down. Plus what? What's 0.25 times?
1.25.
All right. And therefore, if 665 minutes were used, what would be the cost? You said $9.25?
Yes, ma'am.
Okay, great. $9.25 for that cell phone bill. We're going to do one more example, and then we will resume on Thursday. All right. I also wanted to share the best way to contact me is by email at sthomas@lawsonstate.edu. Just in case you need to contact me about anything, that's the best way. I'm on both campuses, so don't call, because sometimes I may be in the hall or something like that. Best way to contact me is by email. All right. Evaluate h of x equals x minus 1 over x plus 3 for the following. So this is called a rational expression, which basically means it's a fraction. All right. So it's a little different because it's a fraction, but we still do the same thing. What does it mean to evaluate a function?
Substitute.
What does it mean? Yep, substitute. What are we substituting here?
Whichever one we're doing first for x.
Okay, let's do this one.
Okay.
So we're substituting what for what?
0 for x.
All right. Very nice. So we're going to have 0 minus 1. That's what we're doing here. Over 0 plus 3. So h of 0 equals what?
-3 over 3.
-1/3.
Yeah, you probably wrote it. You probably wrote 3 twice. -1 over 3.
Yes.
All right. Very nice. Let's move on to h of -1. H of -1. So x is -1 here. So -1 minus 1 over -1 plus 3. So I'll give you a couple seconds to look at that. All right, what do I write next?
Is it -1?
Yes, because what would you?
-2 over +2, which is
Very nice.
-1.
All right, always simplify. Yes, h of -1 equals -1. This one is where I was trying to get to. H of -3. I want y'all to work on that. The last thing we're going to talk about, and then we'll resume talking about domain and some other things that I wanted to get to today, but I just didn't get to it. That'll be Thursday. All right. So what do y'all get? What do y'all get for that?
Undefined.
Undefined.
Oh, look at that. Very nice. Because it ends up being -4 over 0. And that's a problem, right? It's really
Yes.
undefined. So when a 0 is under the line, it's undefined. So that's what I need y'all to circle. Not -4 over 0. I'm looking for the word undefined for that one. So that's